Okay, here we go. All right, number 1 is x equals 7. Number 2, y equals 8. Sorry, let's go. I took it back over there, didn't I? Yep. So for number 1, we know that angle F, where you see the x variable here, angle F corresponds with angle B because of our congruent statement. So angle B is 135. So you can set 10x plus 65 equal to 135 and solve for x. And similarly, we can solve for y because y is here angle E. Angle E corresponds with angle A. So I know they're congruent. Angle A is 28 degrees. And we set that equation up and solve to get y equals 8. Number 3, a congruent statement. There's lots of different ones. You could say angle L and angle triangle, I shouldn't say angle, triangle LJK. And if you say LJK, you need to say RTS. Or you could do JKL, and JKL corresponds to J to K, J to TSR, right? Yeah, so there's a lot of different ones you could do. You had to have the congruent symbol. Make sure you have a congruent statement if you're making a congruent statement. You should. If you didn't, you should in the future. Number 4 and 5 and 6 and 7 and 8, you have to not only show the arrow notation, but give the correct coordinate. So if you're translating 3 left, you have to subtract 3 from x. And if you're moving it down 9, you have to subtract 9 from the y. That gives you -1, -12. For number 5, reflecting across the y-axis means you take the opposite of the x coordinate, but you don't flip anything. So just 0, -2. Number 6, rotating at 90 degrees clockwise, take the opposite of the y coordinate and flip it. So that gives you -4, 9. Rotating 180 degrees for number 7 means you take the opposite of both, but you don't flip. So that's going to give you -1, 3. Number 8, dilating by 2 means you're multiplying by 2, so -3, 6. And dilating by 1/3 means you're multiplying by 1/3. I know that's the same as dividing by 3, but when you dilate, you have to say what factor you're multiplying by. So you have to say 1/3. And that's going to give you 0, -2. Any questions on the front page? Okay, flip it over to the second page. Second page, you can see all of these units. The x coordinate is 5 more than what the x coordinate was before in the original units. And the y coordinate is 3 more than what it was in the original coordinate. So it's been translated, right 5, up 3. Number 11. They took the opposite of the x coordinate and flipped them. Now, I wouldn't be able to tell that information if I only looked at q and q prime, which is why I gave you r and r prime and s prime. You can see they took the opposite of the x coordinate and flipped, which is a 90 degrees clockwise rotation. Number 12 and 13 and 14 were the 3 most missed problems on the test. Number 12 is easy if you follow the primes. The red triangle, shouldn't say triangle, the red rectangle square is the original one. And it moves to the blue one, which moves to the green one. Now, I know your test was black and white, but you can still see the primes. And so the first transformation here was a translation of left and up, left 4 and up 3. And then once they got it to that spot, they dilated it by 4. Those were 2 points apiece. Number 13 can have 2 different answers. And so they gave you the red triangle to start with and asked you how they got to the green triangle, the double prime. They didn't draw the in-between shapes, which I think is helpful if you do. So it's been reflected over the x-axis. It's just a matter of where did they reflect it. It wasn't rotating, because if they would have rotated it, A would have been here and not here, because it would have rotated in a circle like that. So I know it wasn't rotated, but it was reflected. If you said first that you thought it was reflected over the x-axis, that would then take it up here to where this triangle is, which means it would have been translated left and down 1, left 7 and down 1. Okay, so if you follow the blue here, if you said reflect over the x-axis first, then your second transformation would be left 7, down 1 translation. If you said, well, I'm going to move it first, which is completely possible, you could actually have listed the translation first and slid it or translated it 7 to the left and up 1. Then you could have reflected it. over the x-axis. So if you said that, then you would have these purple ones right here. Translation left 7, up 1, reflect x-axis. As long as you had those, you could have either combo and you would still have the correct answer. Number 14, you had to find the original coordinates. And I think some of you just thought, oh, here's some coordinates. You must want me to do these two transformations. I wanted you to do them in reverse order. Okay, you had to do them in reverse order. They gave you the double prime coordinates and asked you to work backwards doing those two transformations to see what the original coordinates were. Now, I didn't practice this a whole lot with you, although we did have a homework question over this. I think this is the homework question you had. So it was a 3-point question. I gave you 2 points automatically. So everyone got a +2 on the top of their quiz. For those of you that got this right, completely right, then you got an extra 2 points. Okay, so I just gave everyone a free 2 points and curved everyone's test 2 points, not the full 3, because I figured if you knew somewhat of what you were doing, you should have gotten something. The only way you missed 3 is if you didn't even know what, you didn't even read the question, basically. Okay, so most of you got your points back on that if you missed it. Maybe you missed 1 out of 3, and so you got +2, so you actually got +1. Maybe you missed 2 out of 3, and if you missed 3 out of 3, then I guess you just missed 1 in that case. Yes.
So everybody got a +2.
I added 2 points to everyone's score.
But then you got the question right.
Yeah, if you got the question right, you missed 0 on that question, and you got an additional 2 points.
Okay.
Yeah, as almost like a bonus then, right? Plus, you could have gotten a bonus, right? Which only one person did. So.
Really?
Who was it?
I don't know. Who was it, Colin? I don't know.
DJ.
Did you get it?
7?
Number 15 and 16. No free points here. You did have to show your work, though. The only way you can tell whether two figures are similar is by checking their sides. Their angles have to be equal. So saying that their angles are equal doesn't say that they're similar, because they could be congruent and still have equal angles. To be similar, you have to have proportional sides. So the 6, 8, and 4, if I match them up with the corresponding sides, all those fractions give you 2/3. That's one way you could show that it's proportional, because your scale factor is 2/3. You could also flip it upside down. Some people had 3/2 instead of 2/3. That's fine. What's the decimal version of 3/2? 1.5. So several of you said multiply them all by 1.5. That works. Okay, it's just the reverse order of 2/3. 3/2, 2/3, same thing. It doesn't really matter which shape you put on top to me. Okay. Some of you said 6 is to 9 as 8 is to 12, and you cross multiplied, and you got 72 and 72. That works as well. Number 16 is not similar, though, because that same thing when you do 15 to 9 and 6, 15 to this 9, length to length, width to width, you end up getting 2 fractions that are not equivalent. Okay, so you get 1.6 repeating and 1.5. 1.6 and 1.5 are close, but they're not the same, so they're not similar.
That's what you do.
Or if you cross multiply, you got 90 equals 81, and that's not the same, so they're not proportional, depending on how you wrote it. Yes.
So you took a 1.5 points off number 15 because of my work, but then I did the same thing on number 16 and you didn't take it. Like I did.
Because you said 0.5. I didn't take any points off. I just substitution 1.5. You said 0.5.
Sir,
But
for number 16,
yeah,
I got the right answer, but I technically did it wrong because I put 15 over 6 instead of
so you probably didn't get the points then.
I didn't say I got anything marked off. Because when it should have been 15 over 9.
Oh, you're right. You're right. I skipped over it. I was apparently grading it too fast and didn't catch it. I appreciate your honesty, though, so I'm not going to penalize you. Third page. They are similar. So now you have to solve for x. So same thing, except now my proportion is going to have an x in it, and I got to cross multiply, and I get 15 for x for number 17. And then on number 18, we get 14.4 for x. Again, set your corresponding sides, ratios, cross multiply, and you solve for x. Number 19, your working with similar shapes here, but they're just describing them to you. Craig's trying to find the height of his tree in his backyard. He measures the tree shadow to be 36 feet. His own shadow is 10 feet. So tree's shadow over his own shadow, tree's height, X, over his own height, 5.5. And you can cross multiply. We'll actually go out and do that here once the weather warms up a little bit. We'll take one of maybe our success time. So we'll go outside, we'll measure how tall that light pole is out there by using indirect measurement, like Craig did, using proportions. Because there's no way we're gonna be able to climb to the top of it and measure it, but we can use shadows and similar figures.
Well, we do the reverse of what Craig did, right?
We'll do exactly what Craig did, except instead of a tree, it'll be a light pole.
Oh,
Number 20, a picture is 8 inches wide and 10 inches tall. So 8 is to 10 as 2.5 is to what? And our new length would be 3.1 inches. If you read the instructions, it said round to nearest tenth. So that would be 3.1, not 3.125. That'd be 3 decimal places. Number 21, the side length ratio is 7 to 4. So the perimeter ratio is the exact same. The area ratio is the square of the side length ratio. So 7 squared is 49 and 4 squared 16. Number 22, the side length ratio is 10 to 12. That reduces to 5/6. And the surface area ratio, the area ratio is going to be the square of that. So 25 and 36. And then the volume ratio is going to be the cube of the side ratio. So 5 cubed is 125 and 6 cubed is 216. It said you had to use reduced ratios. If you just used 10 over 12, you got a correct ratio, but it was not reduced. Had to reduce 10 to 12 to get 5 to 6. Questions on the 3rd page. 4th page. The ratio of perimeters is 7 to 10. The ratio of the side lengths is the exact same. So if you know the perimeter ratio is 7 to 10, the side length ratio is going to be the same. So 7 to 10 is equal to x over 12, and you get 8.4. Number 24, they're asking you to find the missing area. So the side length ratio is 12 to 20. That reduces to 3/5 because it's asking for the missing area. We square that to get 9/25 and use that ratio. And the area is 300 inches squared. Number 25, they're asking you to find the missing volume. The side length ratio is 12 to 24. That's 1/2. Because it's volume, we have to cube the ratio, not square it. That's going to give you 1 to 8. And then we use that ratio to find our missing volume. And that's going to give you 576 meters cubed. And then yes, Ashton.
You marked off for this one. Oh, never mind. I got 579.
Yeah, you didn't reduce it.
Yeah.
So my guess is somewhere in those big calculations you were doing, you just had a typo. Like maybe your calculator said it right, but you wrote it down wrong off your calculator. Could be. It was worth 3 points. You just missed one, right? Yeah. And then the bonus was worth 3 points. It says you have a small marble statue of Wolfgang Amadeus Mozart, which is similar to the original statue in Vienna, Austria, pictured below. Your small statue is 10 inches tall and weighs 16 pounds. The original statue is 7 feet tall. Find the weight of the original statue, round to the nearest tenth. So your statue is 10 inches tall, but the real statue is 7 feet or 84 inches tall. So the side length ratio of those two shapes is 7 inches on 10 inches on your statue is 84 inches on the real one. That reduces to 5/42. Now I'm talking about weight. That's volume. Okay, a little science question for you there. Weight, you're talking about the space inside, the marble that makes up the statue. That's a volume. And because that's volume, I have to take this to the 3rd power. So my reduced side length ratio of 5/42 is going to get cubed to 125 over 74,088. I can then set it equal to 16 pounds is how much my small statue weighs. So how much will the actual statue weigh? Cross multiply, we'll find out that it's 9,483 pounds.
That's a heavy statue.
That's how much you think. Well, you would think a marble statue would be heavy, right? I had some people putting like 100 pounds. Like that's lighter than I am. Like it's
Lighter than I am. That's 40 pounds lighter.
yes. The bonus?
Wait, who got it right?
That guy.
Caleb, that's mean.
Yeah, I'm